Okay, so now that we have our cluster analysis done, and now that we have all of that on a and now that we have all of it with dimensions that we can actually represent our cluster analysis, let's go ahead and let's let me get rid of this here since we're not going to need it. But let's go ahead and get this exported into an Excel file format so that we can go ahead and get this into PowerPoint. Okay, let me just make sure we have all the data that we wanted to have. Awesome. Looks like this is the same. Well, it'd be nice to have that at handy because we'll be referring back to that. Let's from Google Colab, we want to import files, and then we want to use PCA model out dot to CSV, and we'll do a PCA analysis dot CSV. We'll use output, and then we'll do files dot download this CSV file. Okay, and there we go. Now we have all this data. So what our goal is going to be is, let me pull up PowerPoint. We are going to want to, essentially what we're going to be doing is, we are going to be taking, this graph right here, and we want to put it in PowerPoint. Now you can do this and just paste this graph and get full credit. However, I'm going to show you how to do it in native PowerPoint to make it look more professional. So there is a couple things we are going to need to do, and this is going to get a little bit complicated. So let's start off with, we're going to need to have PC1, or here, let me go here. So to create this graph, we are going to use a scatter plot. And when we have a scatter plot, it has a x value, and then it'll have different y values. And you'll see like the y values are what the different colors are. So we can't just say take assign cluster and make that y values. So we're going to have to do something a little bit more creative than that, where we're just going to make this, group 1, group 2, group 3, and then if we'll use an if statement, if this is equal to 0, then this is PCA1, else nothing. We'll do the same thing here. Let me copy this text formula. If this is equal to 1, then this is group 1. Oh, we might want something different than false. What if we just return that? This is equal to 1, then that's in group 2. And finally, if this is in group 3, then return that is in 2 and make it return group 3. Okay, so now I have the data in for our different groups. So I have the different groups, the assignments. I can just call this our X coordinate for right now. And I can copy this into PowerPoint. And now we see that we have our different groups all shown in color, which is very nice. The next step that we can do is we want to take this name column and we would put it in here. Let me make sure that is not being captured in our data. And the reason that I'd want to do this is so I can go to data labels. And then when I go to data labels, we can see that we can then turn off Y. Oops. Oh, I guess we lost those data label. We can go back here, label options. We can say value from cell, and then we can choose those cells so we get flowers. However, the problem with doing this is you can see there's a lot of text overlap. There's not really a great way to get this fixed, but I'm going to show you one possible solution. So let's see, let's say like we have currently 100 values right now, and let's say like we only want to get maybe 20 data points might be good. We can do this. We can use a value, why don't we go with 30? We'll do 30. And in order to choose that, and we'll use a random function, and that'll give us some number between 0 and 1. And then we can do this. We can say, well, if this number is less than 0.3, that would get us, then we return the name. Else, we return nothing. And what this will do is it will get us about 30 flower names that we can use in our data. So that should much help cut down how many flowers we would be looking at. Actually, you know what? I don't know if 30 will be quite enough. Why don't we, let me change the parameters on this so we're cutting it down by half. That'd be 5. So now 1 out of 2. That might be a little bit nicer. Yeah, I guess that's manageable to work with. So let's go back here. Just go to data points from series. Oops, not series names, values from cells. We will click on this again, and oops. Let me highlight that. That will be useful for the other ones. Get rid of the Y's over here. So we don't have those Y values. And then do the same here. And that turns that into flowers. Let me get rid of the Y's again. That's kind of nice, but that's also, that's a little bit more concentrated than I was hoping. Let's move this down to 0.4. copy that back in. Okay, I like that. That's a good number. And then we can just simply go in here and we can start to clean some of these up where we find some overlap. There's going to be a lot in here. Let me clean these up. We don't necessarily want to see everything. We just want to see, oops, a couple of these. And let me get rid of the grid lines while we're at it. And let me move the axes. Axis option. Let's move this to the bottom. -6, and then we can move this one down as well. Okay, that makes this a little bit nicer. I'll come back to that. Let me clean some more of this up. Actually, let me zoom in before I start moving things. Let me zoom in on this just so that we don't let's see, does this work at -0.9? And then would this work at 0.9? Yeah, okay, that's good for that. And then up here, we want to have this -0.5 maybe. Ooh, that one, okay, maybe 0.55. And let's make this 0.5. Nope, we lost data. Let's not do that. 0.6, 0.55. Okay, that is a nice one. And then we are going to want our axis titles on it. So let me hold those in while we're still at it. I'm not the biggest fan of working with in-graph elements like this. Actually, if that one's on the right side, why don't we put this one over here? Oh, that's tough. Um, oh, we gotta get rid of they still have their, oh, never mind. You know what? I take that back. If we want to group these, if we want to have the circles go around them, that might actually be necessary, is to have these axes where they used to be. Um, maybe not. Let me try this. So I want to show that all these are grouped together. I should have moved this before I started picking out where the flowers would go, but that's okay. Um, okay, that is looking good. Want these are still a lot more flowers, I think, than I want. That is just too tight of an area right there. It also is a little bit tight. That's a little much. Okay, let me look at how that. Okay, maybe I would want it a little bit cleaner. Honestly, though, that's not too bad. Lastly, let's shape. Can I edit these at all? Edit some of these points. I don't know if this is really a good idea. Um, okay. I will just leave it at that. Um, let's go back to our code to remember what these axes mean. The x-axis is this. What size are we looking at? It's 13. Sepal length. Petal length. And petal width. Okay. And then this is just sepal width. Okay, I don't know what's going on with the graph. It's just not, the graph is just not sitting with me. Maybe there's just too much going on with it. Let me see what happens when I take off the data labels. That does look a little cleaner, but it does lose information. You know what? I'm just going with the data labels. Okay. From here, what insights do we have? The flowers, the iris data set can be distinctly categorized based off their petal width and sepal width. into 3 groups. Okay. Petal width captures the most variance. Let's see, what does wait, petal width is the best differentiator, making up about 31% of the variance of the x-axis. Okay. Sepal length is the second best. Differentiator is the second best differentiator for grouping, making up let's look how much of this axis making up 16% of the y axis, 16% of the variance of the y axis. Petal width, and let's say sepal, petal width and petal length are highly correlated factors with each other. While sepal width and sepal length are not as much correlated. Okay, and let me put the source as the iris dataset. This data. Okay, so you are free to do whatever you want with this. Just make sure you have some kind of group map. Another thing, this data set isn't particularly too interesting because we're just looking at sepal width and sepal length, so it's harder for me to really create key takeaways of it. But if you're doing the MPG data set, looking to talk about maybe they're grouping cars into these categories because they're faster cars or they're heavier cars or lighter cars or they have better gas mileage and whatever. So try to like figure out what the groupings mean when you do that. Really quickly, I want to show you what another PCA analysis looks like this, but with more of a with a more business use case of it. So let me bring that up. Okay, here's an example of a principal component analysis I did with the airline industry. So you can see that I have the different factors that the airline industry was rated on. We have stage length and travel distance on this axis, and then we have cost and prices on this axis. You can see that we have like this premium group up here, United American, where and this is of 2001, should add that in. But we have this really high premium group up here where United has the highest costs and the highest prices. And then we have these low cost carriers down here. We have Alaska, Southwest, Allegiant. And why this is such a great tool to use, being able to use an unsupervised learning algorithm like this, is it allows you to, in the business world, create industry landscapes like this. And you can really see where the different firms compete. You can see where Delta is relative to its competitors. You can see where Southwest is, and you can it's easier for you to determine, for instance, that, well, Southwest, just by looking at this, I can tell that they're not really a direct competitor with United. In fact, they're much more of a direct competitor with Allegiance than they are with United. And this is all based off the factors that was based off the factors of those different aircraft, of those different firms, or those different airlines. So I'm showing you this just to give you some insight into how these types of graphs are useful, why they would be useful. Product positioning is another great place that you can use this. But when you go through the assignments, maybe use this slide as reference if you'd like to figure out how to better present your data. And with that, that wraps up this assignment. Hope that you found it interesting. I know this one was a lot more, probably a lot more technical than the other ones, but I would just want to reiterate, knowing how to cluster, knowing how to do dimension reduction is a very powerful tool. And dimension reduction is probably the most common machine learning algorithm I use in in the business world. So hopefully you'll find this useful and you'll find applications to use this in the future.